everybody. Fifth and last proof in day 20. This time, pretty complicated. You can see it going off of the page here. We're going to do in-map if and only if from day 15. So before I start highlighting some of the correlations in the proof itself, I want to highlight some differences in terms of just how we're expressing things in general when talking about Coq programs informally versus formally. So like what's worth remarking on? The textbook goes over these bits in detail, but I like to use nil and cons constructors like this when I'm doing informal stuff. So the double cons I just use as 2 colons in LaTeX, but this bad boy, this is a text TT, right? Something like that to get that. I apologize for the truly terrible handwriting there. Let me rewrite that for you. This is how I'll write a nil. I don't know if that's any better, but we'll call it there. So that's one note I want to make. The next note I want to make is that if you go through in Coq, you'll notice that like there's these x's in the exists, and then they show up as x primes elsewhere with this assert, and then we do this other thing with a prime, and like this is not great for an informal proof. I think it's way better if you can to choose fresh names. So what we're actually going to do is we're going to call it z, and then for the exists of the x, it'll be x, and that way we'll always be able to sort of keep it relatively straight. Oops. Keep that back. Okay, so that's another thing. The last thing is I want to note that there's this proposition in, right, that we define as this fixed point on props, blah, 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 back in end of day 15 also. But here, you'll notice the way that we talk about it, so we just say the word in, if y is in blah, right? If y is in, right? This shows up throughout the proof. And on the one hand, I think this is a much nicer way of reading than saying capital letter I in XL or whatever. That's much more awkward than simply using the English idiom, because the English idiom fits perfectly here. But there is a hazard. It's very important that you keep in mind that the definition we're talking about is still capital I in. And if there's any question about what the cases are, as we'll see down here, those cases correspond exactly to the cases that come from the in proposition that we defined. So even if you're using informal language, you don't get to change the definitions informally to suit your mood or convenience. You have to honor the definitions as they are. So even if we're using a more relaxed, informal way of talking about it, make sure that you're still talking about the appropriate Coq concepts. Okay, let's get that markup gone. That's sort of the prolegomenon, which is a fancy way of saying the thing I'm going to say first before I actually talk about the thing. That's my fancy introduction to the informal bits of the mathematics. What remains is talking about how some of the logical reasoning that we see in the Coq shows up here in the informal proof. So first off, we're doing an if and only if proof. So there's a split where there's some cases, right? I'm going to demarcate sort of where those cases are on the left. And you can see that same demarcation here, right? So here we have that, and we have that. I will spend some time in the next video just in LaTeX showing you how to get these nicely laid out lists. Should be helpful. These should actually be indented a bit, but I'm going to leave it because I've had enough technical difficulties with this video that I would prefer not to reshoot. So let me get rid of that mark. So there's the bits of the split. So that much is sort of, okay, more or less like it is in Coq. You have 2 goals for your split. You prove each independently. Here we make I show left to right this way. This is a \capital R right arrow, which is also the symbol I'll use for implies. This is a \capital LEFT arrow. Okay. All right, so far so good. Let's look at the left to right direction. What do we have on our hands? We have an induction. By induction on L. By induction on L. Right, that all sort of lines up neatly. There's some funny business going on here in the base case. Where here this intro is blah. Okay, what you really have is you have this hypothesis, right? That corresponds to this hypothesis, which is contradictory, right? Because there is no y in blah. So this is really at core, this is somebody saying intros contra, destruct contra. And contra here is going to be something that turns into false. In X, empty list is just false, so that blows it up. Okay, that's the base case. In the next case, let's see what goes on. So we have first some this is goal, IH, context, all that information shows up right here. Thank you. I don't need to hear any more about that. After that, we go by some cases. So going by cases again on the hypothesis. So the we have two cases here corresponds to that destruct. Let's do a different green maybe. Right, that corresponds to this. Right, so the we have blah, 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 that's sort of doing the intros. We sort of see it there too. And I just do a little bit of evaluation. So that's maybe the simple. Let me fix that up. There are two cases. That's this part. The simple, right, if we're trying to go one-to-one, right, this is the same as this simple, right? But then if we go back, this is also part of the intros, right? There are two cases is the destruct part of the intros. Now here our two cases correspond exactly to the two cases you'll have for in. So if you look on the left, the first case we have is y equals f of z. And in that case, well, z is the perfect candidate for the thing we wanted to find. And we just sort of use the reasoning that we have immediately. So what in the left-hand side is moderately complex ends up showing up here as this. Right, actually, let me fix the highlighting there. This line corresponds to that, and that line corresponds to that line. And up on the left, the destruct, right, let's get orange is good. This exists, whatever, this corresponds to that line. Okay, cool. All right, the next case, Coq totally loses out to our informal reasoning. The informal reasoning business says, look, the IH gave us such an X, and I'm going to use in such a way as to ignore the left-hand side. So let's line up the bits. Here, our IH gives us an X and L prime such that blah, blah, blah. Okay, that corresponds to this whole assert, all this business. And then really, it kind of also corresponds to this where we're breaking apart that existential package. All right, then the next piece here, well, now on our third green of the markup, right, corresponds to all of this. So a little more logic needs to happen in Coq when we have now here 6 or 7 tactics getting dispatched with just 2 short sentences. Okay, let's briefly look at the other direction. I wouldn't put a QED here at all. Let me remark this. Oops, that's not where you write letters. Should be indented. But these two need to be indented more. I'll fix it on the website after this. Okay, so now in the other direction, it's the same sort of reckoning. So you'll notice in both of these split cases, right, I'm really careful to goal context reasoning, right? Reminding people here's our goal, here's our context, what do we know, what do we need to show? And then we go by induction. Let me get the same color as before, that earlier bright green. Right, so we're going to go by induction on L. Okay, great. By induction on L. Great. So what are the correspondences here? So here we say contradictory. There's no way to have an X in the empty list. We get to do the same thing here. On the other side, what goes on here? Well, here's our sort of goal, context, IH business, not necessarily in that order, just sort of gives us everything. Here, I guess it's context, goal, IH, which is maybe a nice order to do it in more generally, but all of them can be good. So we now say there are 2 cases. Where do these 2 cases come from? Well, they come from our IH. So what's sort of maybe less obvious Or do they come from RH? Yes, no, excuse me. The two cases, I'm sorry for that confusion. The two cases come from here. Right, that's where we get there are two cases, which is why over here we have that destruct H2. Okay, sorry for that confusion. After that, what we have is more or less some reasoning, right? Just to sort of here see that everything lines up correctly. So that looks like this, right? All of this computation corresponds more or less to that, right? Now you'll notice here in the calc we have to name the equations we're using, whereas over here we're sort of like implicitly using like this transition, this f of x to y, is by assumption. Okay, in the next case, we do the same sort of IH-based reasoning we saw before. So we can see that this line corresponds to this line. You'll notice that there's nothing exactly corresponding to these two tactics here, right? We had a pretty good, not in proof, in informal proof. Not in informal proof. So we had a pretty good correspondence going on for how exists got used in Coq and in informal proof. But the left and right subtleties are sort of left out because we assume the reader is kind of following along. Like, look, so one way or another, you need to show X. You need to show that Y is in map FL here. Where L is Z cons L prime. So that means Y is either going to be f of Z or it's going to be somewhere in the tail in map FL prime. And so like we assume the reader is just keeping up with that notion of what it means to prove that something is in a list. Now, if you felt like somebody might not keep track of that, you could put a comment here, right? Explain here two options, right? If you wanted to. I think it's unnecessary in this case because being in a list is an intuitive enough concept. Okay, sorry for this slightly shoddier than usual video. I am really just fighting against my tools so much here. Something changed in a recent update and I don't know how to fix it. But hopefully it's still largely legible to you. I'll have one more video coming out after this, just showing you how to get these nice layouts in LaTeX. All right, that's it for now, everybody. Talk to y'all soon.